DIACalc is a software developed for analysis and design of concrete structures. It is suitable for plain concrete, concrete structures reinforced with conventional rebars, concrete structures reinforced with steel fibers, and concrete structures with combined reinforcement, meaning rebars plus steel fibers. Integrated calculations for ultimate limit state and serviceability limit state verifications can be performed with full access to intermediate calculation parameters. DIACalc was developed in accordance with European standards, namely Eurocode 2, the Portuguese National Annex of Eurocode 2, the German National Annex of Eurocode 2, and a user-defined module is also allowed in order to change some parameters for evaluation of specific calculations. DIACalc can be used in Portuguese or in English. However, for output results, 5 languages can be chosen: Portuguese, English, French, Spanish, and Italian. DIACalc was developed for rectangular cross-sections, defined by width and by depth. The design situations can be persistent or transient, or they can be accidental, with influence on the safety factors shown in these tables. Regarding structural elements available, solid slabs or plates can be chosen, or beams or columns. The choice of the structural element is important not only for the structural resistance evaluation, but also to determine minimum and maximum rebar values, as well as rebar spacings. The materials definition is very simple with DIACalc. The concrete is defined by FCD and by the concrete cover. Alpha CC depends on the code that is being used. Steel rebars are defined by FSYD, and the maximum steel deformation depends also on the code that is being used. The steel rebars can be defined by rebar spacings, or they can be defined by number of rebars, which is more adequate for example, if we are using a column or a beam. Steel fibers can be defined in 2 ways. One way is to define a fiber type and a fiber dosage using the DIACalc database that is included in DIACalc. Another way is to define the residual strength values FR1, 2, 3, and 4 in accordance with the standard EN 14651, which allows the user to use any kind of steel fiber. This allows the user to use a certain number of test results, for instance, for a certain project. Regarding the DIACalc database, it's important to refer that 12 fibers are included: 3D, 4D, and 5D fibers. All the values were provided by Beckert. Fiber dosage values are available from 20 to 40 kilograms per cubic meter. And the DIACalc database is available for concrete classes ranging from C20-25 to C50-60 according to Eurocode 2. The residual strength values for any fiber can be checked in the materials area FR1, FR2, 3, and 4 in characteristic values. It is possible to perform ultimate limit state verifications with DIACalc concerning bending, with or without axial forces, shear, and punching shear. For bending, parabola rectangle stress-strain diagrams are considered, as shown here, to calculate the interaction diagrams that can be presented as MN or, alternatively, as mu and nu. Main results are immediately shown for any situation on the right side of the screen, where we can see steel rebar values, MRD values, with and without fibers, for the axial force considered here. Minimum and maximum rebar values, as well as rebar spacings, are also calculated, and the main intermediate parameters can be easily checked for any situation. Minimum rebar values are shown for crack control criteria and also for ductility criteria. Some rules are also provided regarding rebar spacings when steel fibers are considered. For shear verifications regarding ultimate limit states, VRD values are presented at the right side of the screen, allowing to compare the situations with and without steel fibers. Intermediate parameters can be checked, providing information for concrete, steel fibers, and stirrups. In this case, no stirrups are required because steel fibers are considered. It is important to refer that shear resistance is one of the most important contributions of steel fibers. Usually, a good solution with steel fiber allows not to consider any stirrup reinforcement, which is very important for certain situations, for example, in underground works. We can take out the steel fibers just to see a situation that requires shear reinforcement, and as can be seen, minimum reinforcement values are also calculated, as well as stirrup spacings, and all the intermediate parameters are shown. For punching shear verifications regarding ultimate limit states, a rectangular loaded area is considered, as shown here. The soil structure interaction can be considered, defined by uniform stress, sigma, here, or, when applicable, by a beam on elastic foundation, defined by its width and by the soil deformation modulus. Longitudinal rebars can be considered in both directions. The bending moments can also be considered in both directions. Inclined loads can be defined, as shown here, and the results are shown in this graph for all the perimeters from 0 to 2D, showing the contribution of steel fibers. And the main results are also shown in this table for 0, D and 2D perimeters. The calculation of the critical perimeter is always performed when soil structure interaction is considered. In this case it's 2D, but it could be a different value. Regarding the beam on elastic foundation results, they can be checked here, where you can see the pressure, M and V. And as usual, all the values are available to be checked. If any punching reinforcement is necessary, and for that we have to take out the steel fibers, and let's choose standard DIACalc 2. For that situation, DIACalc provides the definition of a detailed rebar solution according to DIACalc 2. As shown here. It's possible to see the reinforcement values, including minimum values, the control perimeter U out, and the reinforcement spacings, and also the total punching shear reinforcement that can be seen here. Values are always available, showing all the relevant perimeters that were analyzed. It is possible to perform serviceability limit state verifications with DIACalc concerning crack control. You can define internal forces and characteristic values, and this can be done for compression with bending, for tension with bending, for compression only, or for tension only. Or it can be done for bending without axial forces. So any combination is possible. It's also possible to define the duration of loading, short or long, the bond properties, plain or high, the concrete age in days, and the cement class according to your code 2. So let's calculate, and we can see here the results, where you can see the neutral axis that was calculated. You can see the post-cracking results with values for deformations, for stresses, for crack openings, and for crack spacings. Intermediate parameters are shown for the situations with and without fibers. If we choose a situation with still fibers, for any situation, let's keep the same values here. Okay, we can see the differences, and this is one of the major advantages of using steel fibers to reinforce concrete structures, because the crack opening is very different considering steel fibers or not. This has a major impact on durability, for instance. DIACalc allows the user to produce output results automatically in order to easily create technical reports. All relevant calculation parameters are included, as well as diagrams, graphs, and figures. As an example, we will open an existing file. This situation refers to a slab with a thickness of 40 centimeters, reinforced with traditional rebars, plus steel fibers. The objective is to illustrate some of the features regarding the output results. We can adjust the zoom to display the interaction diagram in a more interesting way. And we can also choose for an output language, for instance Spanish. It's important to refer that the output results can be presented in 5 languages: Portuguese, English, French, Spanish, and Italian. Now let's export the output results, which can be done in 3 different modules: one for bending and shear, another one for punching shear, and a third one for crack control. So for the bending and shear, we can name it according to the project and the case we are dealing with. Choose the folder. Okay, for instance this one. Now for the punching shear. Same, we can change the name for this one. And also for crack control. Okay. Additionally, all relevant information can be exported. For instance, let's export the beam on elastic foundation results, which could be interesting. Okay. Okay. Now that we have exported the output results, we can see all the files that we have created. All the files are images that can be easily incorporated in any document. We have identification files and results files. This is for the beam on elastic foundation. This is for the crack control, the identification and the results. This is for bending. We have the graph and we have the identification as well and the results. So the punching shear, the graphic, the identification, and the main results. All this is in Spanish, which is the language that we have chosen. So to finish our presentation, we can see an example of an annex which was built into a Microsoft Word document regarding a punching shear analysis. This is it. So this is prepared just for punching shear reinforcement, with the identification in here, the main results and the graphic, and in this situation punching shear reinforcement was required. So as shown, the output results obtained with DIACalc are easy to export, which is important to quickly create technical reports, and they are as comprehensive as possible, showing all the relevant results and parameters.